Okay, so the questions on page 646. There's four of them. They're with electric field. All of them either give us a Q and an FQ, or an E and a Q, or an FQ and an E. So all of them are with electric field strength, and all of them, angle this. Remember, we have two equations for electric field strength. E is equal to FQ over Q, or E is equal to KQ over R squared. Since they're not giving us any with the R squared, it has to be this one, FQ over Q, that we're going to use. So the first question tells us a charge, gives us a force, and it wants to know the direction of the electric field at that location. It tells us the charge is positive, and it tells us the force is going to the right. If the charge is positive and the force is going to the right, then immediately, right away, you should say, oh, the field has to be to the right as well. Because if you go back to Friday, when we defined the direction of an electric field, it was always the direction of the force acting on a positive charge. So if the force is going to the right and this is a positive charge, then the field must also be to the right. And so then it's just E equals FQ over Q. So it's equal to 4.8 newtons over 3.2 times 10 to the negative 5 coulombs. So that's 1.5 times 10 to the 5, maybe? Yeah. So 1.5 times 10 to the 5 newtons per coulomb, and that has to be to the right because the force is to the right and it's a positive charge. Okay, so that's number one, or not number one, the first one, number 11. The second one says the electric field points due east with a magnitude of 3.8 to the third newtons per coulomb at a particular location. The charge of negative 5 microcoulombs is placed at this location. What will be the magnitude and direction of the force? So this time the charge is negative, so the field and the force are always the same direction for a positive. They're always opposite directions for a negative. So if the field is east and the charge is negative, it means the force must be west. So again, it's E equals FQ over Q. So FQ is just equal to Q times E. So FQ is equal to negative 5 times 10 to the negative 6 coulombs. And you're going to multiply that by, what was 3.8 times 10 to the third newtons per coulomb. So 5 times 3.8 is 19, 19, positive 3, negative 6. I should just do this on the calculator, it'll be quicker. 5 to the negative 6 times 3.8 to the positive 3. Okay, I definitely screwed that up because I did not get 3.8 to the 3. This is why I don't use the calculator. 5 to the negative 6. There we go. 0.019. 0.019 newtons. Works out to be negative, and the negative is just telling us opposite direction to the field. So if the field was east, then the force is west. All right, number 13. Negative charge experiences an electrostatic force to the right. So if it's a negative charge and the force is to the right, then the field has to be to the left. Because for negative charges, forces and fields are opposite. Positive charges, forces and fields are the same. So the field is to the left, and then you just calculate it. E is equal to FQ over Q. So 0.07 newtons to the right divided by negative 2.8 to the negative 6 coulombs. Okay, so 0.07 divided by 2.8 to the negative 6, and you get 25,000. And of course, it works out to be negative newtons per coulomb, and the negative means to the left. Okay? Number 14. A small sphere is placed at a point in an electric field that points due west and has a magnitude of 1.6 to the fourth newtons per coulomb. The sphere experiences an electrostatic force to the east. So the field is west, the force is east. They're in opposite directions. Right away, that should tell you has to be a negative charge. They would be in the same direction if it was a positive charge. So then find it. E is equal to FQ over Q. So Q is equal to FQ over E. So 6.4 newtons over 1.6 times 10 to the fourth newtons per coulomb. If you wanted to call east positive, then west would go in as a negative. 1.6 goes into 6.4 4 times. And then the positive 4 on the bottom. Oops, I don't know what I'm doing. So what is that? That's going to be 4 times 10 to the negative 4, maybe? I think 6.4 divided by 1.6 to the positive 4. Yeah. So this is going to be negative 4 times 10 to the negative 4 coulombs. Okay? So I did those. The maths part was easy. It's the positives and negatives, the east-west directions that I wanted to make sure you got. All right. Then if you flip over, I also asked you to do some on page 655. I only remembered which ones, but I think they were 20, 21, 22, and 26. So for 20, 21, 22, this time it's the other equation. This time they're giving you the charge that's creating the field, and they're giving you how far away you are from it, and they're asking you to find the electric field strength. Okay? So for number 20, it says calculate the electric field intensity at a point 18 centimeters from the center of a small conducting sphere that has a charge of negative 1.8 microcoulombs. So E equals KQ over R squared. So 9 times 10 to the 9th Newton meters squared per coulomb squared. It tells us the charge is negative 2.8 microcoulombs. So negative 2.8 times 10 to the negative 6 coulombs. And it says that it is 18? Yeah, 18 centimeters away. So 0.18 meters. And don't forget that has to get squared. Okay, now the answer you're going to get here is going to be a negative. So it's 9 to the 9th times 2.8 to the negative 6 divided by 0.18 squared. Oh, did I screw up? Did you get a whole bunch of 7s repeating? Negative 7.7 repeating times 10 to the... newtons per coulomb, but I don't really trust my answer. 9 to the 9 times 2.8 to the negative 6 divided by 0.18 squared. Oh, that's what I got, except this time I got to the 5th instead of to the 3rd, so I might have counted wrong there before. Okay, what does the negative mean in this case? Remember that this is the central charge. This negative means going which way? Which way were the field lines? Towards or away on a negative charge? And they're towards. So this means towards charge. Okay? Because this time it's the central charge and it's saying the field is directed inward. Alright, we might have time to start the next one before my video runs out. Electric field intensity at a point 0.2 meters away from a point charge is 2.8 to the 6 newtons per coulomb. What is the magnitude and sign of the charge? So this time, still E equals KQ over R squared.